All right, so here what we're going to do is we're going to use these reference angles in order to calculate trig function values for any angle theta, for any angle. I mean, theoretically, we could use the formal definition, but we would have to figure out, though, what that point P is. The point that the terminal side of the angle intersects the circle with. Unfortunately, that can be very, very challenging, but reference angles, as you'll see, are a much easier way to get the trig functions. So what are we going to do? Well, as you can see here, first we're going to calculate the reference angle. Then we have to get the trig functions at that angle, at that reference angle, And then what's going to happen is, as you'll see in the examples, depending on what quadrant the terminal side of the angle is in, you're either going to have to negate the trig function values or not. It depends on what quadrant you're in. If you remember, we had, let me write it over here actually, this thing where we had all students take calculus. So again, this is telling us here in what quadrants, what trig functions are positive. The A, remember, stands for all, meaning all the trig functions. And when I say all here, I really just mean sine, cosine, and tangent. But again, remember, if you really know sine and cosine, you know the other trig functions because they're expressed in terms, they can be expressed in terms of sine and cosine. We have T here, which is tangent. That means this is quadrant 3. And that means that the tangent trig function is positive and the others are negative. This is quadrant 2. I think I skipped it by mistake. The S means that sine is positive and nothing else. Cosine C stands for cosine, so only the cosine is positive. And the A, as I said before, means that they're all positive. But anyway, let's do this example first. So what we're going to do here is we're going to calculate cosine, sine, and tangent of 150 degrees. Okay, so here let's do this. So we're going to draw the angle 150 degrees first. Okay, so that's not so bad. So again, when I say draw it, I mean draw it in standard position. Remember, for a reference angle, you're drawing the angle itself in standard position. So we have here, right, this is the initial side, and this is 150 degrees, so that means it's in quadrant 2. If you remember, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is, of course, 0 degrees, but it's the same thing as, it's coterminal with 360 degrees. So now we have 150 degrees is in quadrant 2. Okay, that's what theta here is. So theta here is 150 degrees. Let me just do that, make it easier. Well, there we go. So we want theta sub r, right? Well, theta sub r, that's going to be this, the reference angle here. This is theta sub r. Now, theta sub r, if you remember, the way we get this angle is we're going to take 180 degrees, right? This whole thing up here, and we're going to subtract off this part, like so, which is 150 degrees. So in other words, the angle is going to be, here, let me do this. The angle is going to be, the reference angle is 180 degrees minus 150 degrees, which is 30 degrees. So in this case, the reference angle is 30 degrees. So the reference angle here is 30 degrees. Okay, so what does that tell us? That tells us a few things. That for one, cosine of 150 degrees, that's going to be cosine of 30 degrees. But again, since we're in quadrant 2, let me scroll back up, the only trig function that's positive is sine. Tangent and cosine are negative. So what we have to do here is put a negative in front, because cosine has to be negative, okay? So that's why we have this negative, that's why we put this negative here. And if you remember, cosine of 30 degrees is the square root of 3 over 2. So we're going to have this. Negative the square root of 3. No, excuse me, I think it's a half actually, I'm sorry. sorry, I was right, cosine of 30 degrees is radical 3 over 2. So we're actually going to get here negative radical 3 over 2. Okay, good. Now for sine of 150 degrees, so here we're going to have this. But again, since we're in quadrant 2, our answer for sine of 150 degrees, has to be positive. So we're not going to negate this. And here we're actually going to get just 1 over 2. Finally, tangent of that, which is 150 degrees, right? That's going to be, we put a negative in front because our answer has to be negative. And we're going to have tangent, negative tangent of 30 degrees. That's sine over cosine, so that's going to be 1 over radical 3, which of course is the same thing if you rationalize. I don't have room here. That's the same thing as radical 3 over 3. So here is another example. So here we're going to find cosine of 300 degrees, sine of 300 degrees, and tangent of 300 degrees. And basically what we're going to do here is, we're going to use reference angles. So to use reference angles, what do we have to do? We have to calculate the reference angle. So to do that, well, let's draw 300 degrees in standard position. So we have 300 degrees, right? So let's draw it. So we have this. So again, we have 0 degrees here. We have 90 degrees here. Here's 180 degrees, 270 degrees. Okay? So where's 300 degrees? Well, that's going to be in quadrant 4. Okay, so let's draw that. So it's going to be down here, like so. Okay? So this is 300 degrees. Now, so in this case, we're going to take theta to be 300 degrees, okay? So this is 300 degrees. So what is the reference angle here? Well, the reference angle in this case is going to be here, okay? So that's where the reference angle is. Now, how do we calculate that? Well, again, we know that the full rotation is 360 degrees. Sorry, this is 360 degrees, okay? So how do we get the red part? We have to subtract. So let me say it again. How do we get this piece? We have to throw this piece away. Now, how do we do that? Well, we just subtract. So we're going to have then 360 degrees minus 300 degrees. No, excuse me, it's 300. Yeah, that's right. Sorry, I thought it was 330 for some reason. But we're going to get 60 degrees, as we can see. We're going to get 60 degrees. Okay? So that tells us the reference angle is 60 degrees. Now, what does that tell us? That tells us sine of 300 degrees is equal to sine of 60 degrees. But again, you have to remember also, in quadrant 4, the only one that's going to be positive is cosine, right? Remember, all students take calculus. We're here now, right? Only cosine is positive. So that tells us sine has to be negative. So we're going to get negative radical 3 over 2. Again, sine of 60 degrees is radical 3 over 2. Cosine of 300 degrees, again, we have the reference angle. We're going to have cosine of 60 degrees. Okay, and again, cosine's positive, so we're not negating it. So in this case, what are we going to have? We're going to have just a half. Finally, tangent of 60 degrees, tangent of 300 degrees, okay? That's going to be negative tangent of 60 degrees. Again, tangent has to be negative. Remember, a trig function of an acute angle is always positive. It's always going to be positive. So what do we get here? What we're going to get here is negative radical 3. Okay? That's what tangent of 300 degrees is. So that's what we get here. Okay, now why is this like whole method even working? That is, why is this reference angle business even, what's really going on here, in other words? Well, let's take a look. What I'm going to do here, as you can see, I'm going to assume our angle theta is in quadrant 2. Does it have to be normally? Well, of course not. But just to give you an idea as to what's going on, I'm going to take theta to be in quadrant 2. So, okay, so here's the angle, let's say theta. Now this is in standard position. Okay, so here is our angle theta. And now we know theta sub r is going to be this, right? That's what theta sub r is. Okay, you know, the reference angle, as we know already. So let me just finish drawing this. Okay, now let's also draw the unit circle, okay? Because if you remember, the trig functions are defined using the unit circle. Okay? So our point P, in other words, here, that's going to have coordinates x and y, right? As we know, see if you can see that. But we actually get a triangle out of this, right? You know, I could draw a line that's perpendicular with the x-axis. Actually, let me just fix that. I mean, it's not wrong what I wrote, but it looks better to put it over here. Okay? We also have this here, the base, and we have the hypotenuse. So let me draw that triangle down here. Okay? Now, hopefully you can tell theta sub r is this angle here. Now, it's the unit circle, as I said, so this is length 1. Now, what about the other side lengths? Well, the height of the triangle, right, the length of this side here, that's what the y-coordinate is. That's what the y-coordinate gives us. What about the length down here? Well, you got to be careful because remember, x is negative here, right? This is where x is negative, but we want the actual length. That's why we actually have the absolute value of x. Okay? Remember, because we want actually distance. But the absolute value of x being negative, is negative x. So actually, the length of the base down there is negative x. So this might be drawing a lot more than necessary, but what the heck? Here's y, here's negative x, 1, here's our angle theta r. So we want to figure out what x and y are, right? Okay, well, by basic right triangle trigonometry, we know that sine of theta sub r, that's equal to opposite over hypotenuse, which is just y. We also know that cosine of theta sub r is negative x over 1, which is negative x. So you can see how we got x and y. But if you also remember by definition, okay, if you also, excuse me, let me just fix that. If you also remember by definition, x is also cosine of theta, and y is sine of theta. So really what we have up here is sine of theta r is equal to sine of theta. And cosine of theta, right, negative that, is actually cosine of theta sub r. And hopefully you know from basic algebra that this up here, you could just bring the negative to the other side, and you get cosine of theta is negative cosine of theta. Oh boy. Negative cosine, so you can draw this of theta r. And that's why. That's the idea behind why this works.